Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. In today's video, we are going to talk about constructing the tip on a pair of gears. This chapter series 13.5 is a part of a four video series on the topic gear fundamentals. Okay, you will in the previous video we talked about gear fundamental. This is the second video, maybe third video and fourth video. This chapter is taken from the book Shigley Mechanical Engineering Design. Okay, so let's begin. Okay, when two gears are in mesh, the pitch rolls on one another without slipping. Okay, designate the pitch ready as R1 and R2 and angular velocities as Wi and W2 respectively. Okay, the pitch line velocity is V. Okay, let me explain. When two gears are meshed, okay, this is gear 1, this is gear 2. You have my finger example as a pitch. This is my finger example as a pitch. Connect together, this meshing. Okay, this is called meshing. And you can see, you can count how many fingers connected. Of course, there are my human fingers have 5 finger, 10. So meshing will be 10 fingers meshing. So, okay, the pitch ready is R1 and R2. Okay, angular velocity is W1 and W2. Okay. In understanding this, I really advise you to have the nomenclature of gear beside you, meaning that if you have the textbook, better. If you can print out the nomenclature, it's also better. Have it beside you because you will see some terms. When I mention pitch ready, you can see the where is the location of pitch ready. When I mention the pitch line velocity, you can also see the location of pitch line velocity in the nomenclature. Okay, so basically the gear have pitch. Okay, this is the baseline of a gear. This is the pitch. Okay, this is the pitch. Okay, okay, and this is another gear. This is another gear. Okay, you can call it as gear 1 and gear 2, and this is the pitch. Okay, these both are called a pitch, and you can call it as the pitch have radius, and this is R1, R2. Okay, and both are traveling at certain velocity, certain velocity, and it represented by W1 and W2. That is what the slide means. Okay, and then when both are connected together, of course both gear will travel at the same velocity. Okay, and then this velocity is called pitch line velocity. Okay, pitch line velocity meaning the pitch velocity of the gear combined. Okay, there cannot be one gear travel at different velocity because the gear will not be stable. Okay, so that's the relationship between the radius and the angular velocity is this is the relation Wi per W2 equals to R2 per R1. This is the relationship between both. Okay. So suppose we specify an 18 tooth pinion to match with 30 tooth gear, and the material pitch of the largest gear set is to be 2 teeth per inch. Okay. Then from equation 13.1, the pitch diameter of pinion and gear are respectively this. Let me explain first. Uh, if you can imagine the picture of the question, 18 tooth pinion matched with 30 tooth gear. This is like resemble like this. Okay, this image I taken from Google Images. Okay, one gear is small and one gear is big, and the small gear is pinion, and the big gear, larger gear is the gear. Both are gear. Okay, but the definition is pinion because this small gear is connected to the motor, and it is connected to the shaft, and the shaft is connected to the motor. And when the motor move, the shaft move, and the gear move, and this gear transmit the force to the larger gear, and this is called the pinion. If the situation is reverse, meaning that if this larger gear is given the shaft, it given the motor, and it transmit the force to the small gear, and this is called the pinion. This, okay, pinion is the gear that give the force. Okay, and the metal pitch of the gear set is to be 2 pitch per inch. Okay, if you have the nomenclature of the gear beside you, you can see what is the definition, what is the pitch location. Okay, I draw like, okay, I draw. Okay, this is the baseline of the gear. This is the pitch, and this is the pitch. The gap. Okay, this is another gear. The gap between. This is the. Okay, this is. Okay, this is the location of a pitch. Location of a pitch. Meaning that from this distance until this distance, this is called the pitch. Okay. So how many gear you, if you can take your ruler, you can take your ruler, you measure 1 inch. Okay. How many teeth in 1 inch? Okay. Maybe you this for this question case, there will be 2 gear. There will be 2 teeth in 1 inch. Okay, 1 inch. There will be 2 teeth in 1 inch. Okay, smaller gear they have smaller teeth. That is what how you try to imagine this question. This is how you learn. Okay, so this is the D1. Okay, pitch diameter. Okay, and N1 is the number of teeth. Okay, and P is the pitch. Okay, and this and D2 is also the uh, diameter. Okay, and N2 is the number of teeth, and P is the pitch. Remember, always pronounce it as full name, because uh, you can find the word N in other subject, in other topic. They represent the velocity. Okay, and this topic of gear, it represent the number of teeth. Okay, don't be confused. Always mention the full name. Okay, so the first step is to in drawing teeth on a pair of mating gears is shown in figure 13.9. Okay, this is the figure 13.9. The center distance is the sum of pitch ready in the case of 12 inch. Okay, so locate the pinion and gear center O1 and O2, 12 in part. Then construct the pitch circle of ready R1 and R2. This tangent is called pitch point. Next, draw line AB to common tangent through the pitch point. So, what does in this slide mean? Meaning that it is suggested that you manually draw, sketch and everything. Okay. Uh, when you are drawing it properly, you will find that uh, this line up until this line is 12 inch. Okay, I don't draw it. Okay, I don't draw. I just try my best to explain to you what does it mean. So this location distance from this line to this line, if you measure with your ruler, it will be 12 inch. Okay. Okay. So we now designate the gear 1 as the driver. Since it is rotating counterclockwise. So draw a line CD through point P and angle theta to the common tangent AB. So again, the term driver and the term pinion, it is the same thing. Driver opposite is driven. Pinion opposite is rack. We will learn about a rack in later on in the other videos. But It's the same thing. The one that give the force is the driver. Also, is called a pinion. Okay. So this is gear one that give the force. Okay, gear one. You can see here the picture R1, meaning that this is the gear one and this is the gear two. Okay, and the line CD from this is the line uh, of action, line C up until line D, and it is called as three names: as pressure line, as generating line, as line of action. Both referring to the same line. This line. Okay. It presents the direction of horizontal force act between the gear. The angle detected D, called the pressure angle, usually has value 20 or 25 degrees. You will learn about pressure angle in later on in other videos. Okay, it is important to know what is a pressure angle, uh, but you will learn in other videos. Okay. Okay, next on the each gear, draw a circle tangent to the pressure line. Okay, the circle are the base circle, so they are tangent to the pressure line. The pressure angle determines their size. Okay, radius of a base circle is RB equals to R cos theta, where R is the pitch radius. This formula you have learned in your mathematics class during your uh, secondary school. Okay, secondary school, when you learn mathematics from your teacher about the perimeter, meaning this is the formula given: R cos theta, meaning what is the distance, what is the, if you can expand this circle, let's say this is a curve, expand it to become a straight line. How long is the this straight line? This is the formula: R cos theta. Okay. And now generate an involute if a circle as previously described and shown in figure 13.9. Involute is to be used for one side of the gear. It is not necessary to draw another curve in reverse direction for the other side of the tooth because we are going to use a template. Okay. Now, how to draw involute? Have I have explained in the previous video. Okay. In the previous video. Okay, you can see the previous video about involute profile. Okay, so the addendum and the addendum distance for standard interchangeable teeth are, as we shall learn later, is 1 over P and 1.25 P respectively. Okay, we will learn later about this, but have your nomenclature to you with you. Is that you can see where is the location of addendum, when is location of the addendum. Okay, let me draw. Okay, this is a circle, the pitch of the gear. If you can divide the pitch between two between two parts, okay, where this is the pitch, this is called the center line is called the pitch circle. It's called the pitch circle, and then for both gears part, they are called addendum, upper part, and the bottom part is called the addendum. Okay, so in this case, the height of addendum is 0.5 inch. You can see here, where is the inch? 0.5 inch. And the height of the addendum is 0.625 inch. You and the height of the teeth is you plus both one. 0.5 plus 0.625, you can get the number, and this is the teeth height. Okay, 1.1 inch, something like that. 1 inch, something like that. Okay, what is the relevant to learn about addendum and addendum? You can see in the other videos I will explain. The wear and tear will happen at addendum first. Addendum will become wear and tear first, and then uh, followed by the addendum, but we will discuss in other videos. Okay, we will discuss in other videos about it. Okay. Next, using a heavy drawing paper, preferably the sheet of 0.015 to 0.02 in clear plastic, cut a template for each envelope. Being careful to locate the gear centers properly with respect to each envelope. Figure 1311, this is figure 1311. It's a reproduction of the template used to create some illustration for this book. Note that only one side of the tooth profile is formed on a template. To get the other side, turn the template over. For some problem, you might wish to construct a template for the entire tooth. Okay, this is O1 and O2. I don't draw it for this video. You can draw it. You can try to make the template. Uh, just refer to this 01, O2 and O1. Okay. After you have drawn the circle in the previous slide, you have to draw this and then uh, mark the location of O1 and O2 so that you can put in onto your drawing perfectly coincide with the location of the drawing. Okay. To draw a tooth, we must know the tooth thickness. So circular pitch is like this, 1.57, meaning that if you plus addendum, this is the thickness. Okay, 1.57 inch, and therefore tooth thickness is 0.785 inch measured on the pitch circle. Using this distance from the tooth thickness as well as the tooth space, draw as many teeth as desired using the template. If you can see in the previous video, they will become in the previous video. No, in the previous slide. In the previous slide, I sketch. This I sketch. This is O1, O2, and O1. Okay, O2 and O1. Between them, there will be how many teeth? Uh, draw as many teeth as possible. Okay, how you can get you can get how some amount of teeth, and the teeth thickness is 0.785, meaning that this is the thickness. Okay, this is the height. They become the addendum and dedendum, and this is the thickness. The thickness of the teeth, not the height. The height is addendum and dedendum. This is the thickness. Okay, and in figure 13.12, only one tooth has been drawn on each gear. You may run into trouble in drawing this teeth in one of the base circle happen to be larger than the dedendum circle. For the reason for this is that the involute begins at the base circle as undefined below this circle. So in drawing the gear teeth, we actually usually draw a line, line for the profile below the base circle, the actual shape. However, we depend on the kind of machine tool to form the teeth. Okay, that is how the profile is generated. Okay, the portion of the tooth between the clearance circle and the circle refers includes in the fillet. The distance is C equals to B minus A. You get 0.15. What is the clearance? You can see you can refer to your nomenclature. You can see there must be a clearance. Okay, there must be a clearance. The clearance doesn't show in this picture, but everything must have a clearance so that the oil, the lubricant, we can flow below the clearance. So, because and in gear we don't want the tip of the gear to touch the base, the base of another gear, because it will be, because that gear will damage easily if the tip reaches the bottom of the gear. Okay, so uh, that's that's all for the video today. We see you in the next video in the part 3 of this chapter 13.5 fundamentals, which we continue with the constructing the teeth of the gears. Okay, so thank you very much.